Hello and welcome to another episode of Smart Prosperity, the podcast, a bi-weekly show about the green economy in Canada, the current affairs, the business, the technology, and the ideas at the intersection of the environment and the economy. I'm your host, Eric Campbell. On today's show, is getting Canada's greenhouse gas pollution down to net zero even possible? A new report says yes, and the report's lead author, Jason Dion, is here to tell us how. Then, clean tech expert Devin Todd walks us through a suite of technologies that remove carbon pollution from the air. Many are calling it a game changer in the fight against climate change. Is there a catch? We'll find out. And after that, we get the 60-second treatment of a major new report, and Mike Moffat wraps it all up with a look at 5 other things happening in the green economy this week. That's today's agenda. Your green economy update starts now. Last November, Canada joined what is now more than 100 countries in pledging to be carbon neutral by the year 2050. In other words, those 729 million tons of greenhouse gas pollution that Canada releases annually, according to most recent data, reduced down to zero, or to net zero, by removing Canada's remaining emissions from the air. Now that gives Canada 30 years. But anyone looking at the last 30 years, where Canada's emissions have mostly only ever increased, would be forgiven for being skeptical. In fact, Canada's emissions today are 20% higher than they were 30 years ago. So can we really bring them down to net zero in the next 30 years? Well, on February 8th, the Canadian Institute for Climate Choices released a much-anticipated report on the ways in which Canada could, in fact, achieve net zero by 2050. And now we get to ask the tough questions of the report's lead author. Jason Dion is Director of Mitigation Research at the Canadian Institute for Climate Choices. Thanks for being here, Jason.
Thanks for having me.
Jason, given how Canada over the past 30 years has struggled to get even the smallest decrease in carbon emissions, there might be surprised that there is not only one pathway, but more than one pathway to reaching net zero emissions in the next 30 years. How many pathways did your report find? And without getting into too much detail just yet, how are these pathways different from one another?
Yeah, so what we've done in our report is looked at over 60 different potential routes Canada could take to get to net zero. So these all represent different possibilities. They are all theoretically possible. That does not mean that they're equally likely. So certainly some of them would come with more barriers and challenges than others. But what they show together is that not only is there a way to get there, there's multiple potential ways to get there, but getting there is going to require strong policy. And that's been the missing ingredient historically, that like other countries, we've been really good at setting targets and then missing them. Right now, we have, with the federal climate plan released in December, a plan that can get Canada to its 2030 target. So our action is going to be consistent with our ambition, which will be great. But getting all the way to net zero is going to require even more. So that's a finding that we underscore always alongside that finding of it's doable.
So over 60 pathways, over 60 routes, as you call them. What are the main tools and technologies that are going to play the biggest roles in Canada getting to net zero?
Yeah, so one of the critical things that we observe in this analysis is that, well, when we look across all of these 60 scenarios, there's a set of things that show up again and again. They're always there, no matter how the transition plays out. And we call these safe bets. So the safe bets are things that are commercially available today. There's no major constraints to scaling them up, and they're going to be there no matter how it plays out. It's a familiar list. It includes things like renewable electricity, electric vehicles, electric heat pumps in buildings, methane reductions in oil and gas. So these are critical things, and they're critical to getting to that nearer term 2030 target. You can then distinguish those from the wild cards. These are the things that are in early stages of development where there might be barriers or concerns around how scalable they prove to be. They only play a role in a subset of our scenarios, but they're really critical potentially to unlocking the deeper cost-effective reductions that can get Canada to its longer-term target. And they include things like hydrogen production, like renewable natural gas made with second-generation feedstocks, and even negative emission solutions that can suck carbon dioxide out of the air and bury it underground. So a lot of uncertainty with what role those solutions will play, but also a lot of promise.
Right, and so across all of these scenarios, these different solutions kind of play together in different dynamics. I'm interested especially in what your report found on these negative emissions technologies, which look like they're going to play or could play an important role in Canada's net zero future. Can you tell us a little bit more about the scenarios that include these kinds of technologies and what role you think they'll play in Canada getting to net zero?
Yeah, so we've got some scenarios where these things prove to be available. They prove to be cost effective enough to get deployed at scale. But we've also got scenarios where we've sort of closed that off and said, okay, maybe these things don't work out. They don't prove to be cost effective enough. So the first thing to note is that Canada can get to net zero without these things. So our scenarios find that there is a route to net zero, even if we don't have these sort of whiz bang future technologies of negative emissions. But where they are available and they are cost effective, they can really help us to avoid directly reducing at source some of the parts of our emissions that are really hard to do directly. So including industry, things like cement and steel, we can offset those emissions with negative emissions instead. So it makes the job easier in a way. And in our most extreme version of it, we could see a lot of uptake of these. So at a massive scale. Now, a lot of barriers and challenges and caveats come around a future like that. But it is an important possibility that we know. So overall, we'd say that these things sort of represent the ultimate wild card. They could change everything or they could change nothing. Really important to pursue them as an option, given all the potential that exists around them, but not something that we want to bet the house on. To go big on these and assume that they'll work out is a really risky proposition.
Jason, in my intro, I mentioned how Canada's emissions have been stubborn over the past 30 years. When we've had decreases year over year, they've been small decreases. Generally, we've actually had an increase over the past 30 years. And I think that's an indication that Canada's economy is actually fairly carbon intensive. So a question that comes up naturally when we talk about getting to net zero emissions is, what are the impacts going to be on the economy? Does your report have much to reflect on that?
Yeah, so alongside the report, we put out a blog on this very topic of what our analysis finds for GDP. Now, I'll start by noting that it's notoriously difficult to predict future economic growth, and we're looking as far into the future in this thing. We're looking 30 years out, and if we look 30 years back, the internet didn't exist, so we couldn't imagine the digital economy. So we don't know what the future holds, but let me map it out in terms of what we do find with that caveat in place. So we find that across all of our scenarios, the economy grows on the path to net zero. So regardless of which solutions and which mixes we end up using, the economy continues to grow. Now, there's only one or a subset of scenarios where the economy might contract in that final last leg of the journey. So between 2045 and 2050, when we're, all the easy stuff's been done, it's only the hardest things. And rather than being a prediction that, the economy will decline in that last time step, what this finding really underscores is that absent significant progress on those wildcards, we could expect some economic challenges. And that underscores the importance of pursuing and developing these wildcards, a number of them, so that we can sort of have options when it comes to that last leg, because there could be some really difficult challenges associated with going the full distance on that net zero target.
What do we do with this information, Jason? Now that we've got these 62 potential pathways to get us to net zero emissions in 2050, they all differ from one another. There's choices that are embedded. What do you want government, what do you want other people to do with this information now that you've put it together?
I think what we've been able to show is that while the future is uncertain in terms of exactly how we would undertake this transition, there are plenty of parts of it that we can understand with confidence. And I think that's really underscored by the safe bets and the wildcards. The safe bets play a huge role, especially in getting Canada to 2030, even in our scenarios where wildcards are working out in a big way. So they are things we can move forward with confidence, sort of no regrets actions, because they're going to be there no matter what. And so that underscores that in terms of deployment and uptake, it is time to drive forward with these solutions. Let's go. Whereas with the wildcards, it's more a matter of advancement and development, that we need to get these things ready for when we need them. Now, both of these things have to happen at the same time. We have to be going forward with deployment on the safe bets and advancing the wildcards. We can't wait on either, but we can't let one serve as a distraction from the other. So I think that's the critical takeaway. We need to drive forward with both of these in parallel. We need to walk and chew gum at the same time.
Jason, what comes next? Now that you've put out this major piece of research, what does the Institute do next?
We're going to be convening regional discussions to sort of talk about what our results say at the regional level, what it means for economic development and GHG reduction priorities. So really starting to connect this in terms of, here are the options. So now that we know that, what do we want to do? That to our mind, that's the really important next step.
Jason, thanks so much for giving us a really quick breakdown of what is a very hefty and authoritative report. Congratulations on getting out, and thanks for giving us an inside look today.
Thank you.
That was Jason Dion, Director of Mitigation Research at the Canadian Institute for Climate Choices. To learn more about the 62 scenarios in which Canada could hit net zero emissions by 2050, we've got links for you at the podcast webpage at podcast.smartprosperity.ca. Now, we just heard about it from Jason Dion. If Canada is going to become carbon neutral, there could be a role for something called negative emissions technologies. In fact, the world is depending on it. The International Energy Association models that about 20% of the reductions needed in the global energy sector to reach net zero will come from these kinds of technologies. So it's about time we got to know a little bit more about them, don't you think? To help do that, I've invited Devin Todd. Devin has worked with a number of clean technology startups and investors. He's currently the researcher in residence for negative emissions technologies at the Pacific Institute for Climate Solutions. I'm reaching him in Victoria, BC. Hi, Devin. Thanks for joining.
Hi, Eric. Thanks for having me.
Okay, Devin. So give us the 101 on negative emissions technologies. What exactly are they?
So negative emissions technologies, you might also hear the word carbon dioxide removal, are human activities which remove carbon dioxide from the biosphere, our oceans, soils, and atmosphere, and locks that carbon dioxide away in a durable way.
So human activities that remove carbon or greenhouse gas emissions from the places we don't want it. What can you give us a little bit more detail? What are some examples of the technologies that we might find in this space?
Yeah, negative emission technologies, it's really a catch-all. And what's important is the outcomes, not so much what's in the box. A few ideas that you might already have heard of include afforestation and reforestation, so planting trees, direct air carbon capture and sequestration, so we have machines that extract CO2 from the air that we then put underground or into long-lived products. And then we also have bioenergy and carbon capture and sequestration. So you take those trees or other biomass, burn it for energy, but capture the CO2, and again, take that CO2 and put it underground or into durable products.
So, Devin, this notion that, up until now, in order to meet our climate goals, we've focused on this idea that, we need to reduce the amount of carbon emissions that are going into the atmosphere. Negative emissions technologies kind of give us another approach where we can actually start pulling emissions out of the air. And as you say, this can happen through nature-based solutions like trees and forestation, and through machines. I'm interested a little bit in the machines. Can you tell us a little bit more about some of the machines that you're seeing in this space?
Sure. So a few examples of the engineered solutions for sucking CO2 out of the atmosphere. Particular companies include Carbon Engineering in Squamish, British Columbia. We have Climeworks in Switzerland, and we have Global Thermostat in the United States. I'd also mention, I think that Climeworks has a joint venture of sorts with another Canadian organization called Svante, who are also pioneers in the point source carbon capture space.
What does a machine that sucks carbon dioxide out of the air look like?
The name of the game for these machines is to have a surface area in contact with the atmosphere. You need to pass a large amount of air through these machines in order to harvest the lower concentration of CO2 that is existing in our atmosphere. Imagine thousands of your air conditioning units that you might see atop a building arrayed in a modular grid stretching for, say, 10 meters tall and 100 meters long as, say, one module. And several of these modules might comprise a larger plant or facility.
So maybe something with the same footprint as some of these big solar farms that we see?
Yeah, like a large solar farm. That kind of land use intensity, you can make it as big as you'd like. There are some economies of scale where a larger facility, you can save on some overhead, but very much you have the ability to, for the most part, these are modular systems, add more modules to increase your sequestration capacity.
Devin, so you've got these machines that are removing carbon from the atmosphere. What do you then do with the carbon dioxide?
Well, you want to lock it away where it's not going to get out. And there's two general categories that you can look at. We can look at utilization or sequestration. Examples of utilization where we have more durable products are in plastics manufacturing. You can build building materials such as concrete. Sky's the limit in terms of what we can conceive there, as long as we're talking about products that are going to be around for many decades and centuries. On the sequestration side, we have two broad categories, and that's looking at resources that are purely sequestration. So we're putting it underground, nothing else going on there. That could go into saline aquifers or reactive mineral reservoirs. On the other hand, we also have enhanced oil recovery or enhanced hydrocarbon recovery in general. And there, we're trying to fit some CO2 into these reservoirs where simultaneously the CO2 is being used to stimulate additional fossil fuel extraction. The hard challenge there is that it's an attractive proposition for organizations trying to undertake carbon capture because you can sell the CO2 to these oil and gas companies. But the question, and it comes down to the project specifics and how it's operated and the geology, is whether there will be a net storage or if we're just creating a lower carbon intensity fossil fuel product in the end.
Yeah, that last one sounds like you're undoing some of the good that you're doing by capturing the carbon dioxide in the first place. Devin, when are we going to see more of these in action? In the recent report from the Canadian Institute for Climate Choices, which we just covered, they talk about it as a wild card technology, one that is not commercial already. Do you agree with that? And when do you think we'll start to see more of these implemented?
There's no particular technological barrier to deploying these right now. There's certainly engineering to do for scale up, but the fundamentals are known and there's no unobtainium involved. From a more business perspective, we can also consider nets being a system with a lot of components, and you need everything along that chain to work. You need the machine to take the CO2 out of the atmosphere, to transport it, as well as to put it somewhere. And there's no robust market right now for each of these parts. And so the early stage commercial projects that we do see deployed right now, for example, Carbfix in Iceland, or we have an ethanol biorefinery facility in Decatur. These are operations that have closed the circle, if you will, or rather the linear pathway, taking the CO2 from the atmosphere and putting it underground.
Let me ask you one more question, which I think is a question on a lot of people's minds, which is this a technology that we can, all of a sudden there's a bunch of money, a bunch of investment that's ready to go into it, no matter what the costs. Can this technology undo climate change?
No, not. I don't think it's reasonable to expect us to remove all the CO2 that's already out in the atmosphere since the Industrial Revolution. They are essential. They are essential to meeting our Paris targets in all likelihood. But it's not a panacea.
Devin, it's great to have you on the program today. Thanks for giving us an overview on these negative emissions technologies.
Thanks for having me, Eric.
That was Devin Todd, researcher in residence at the Pacific Institute for Climate Solutions. Now, Devin has kindly made some recommendations for further reading on negative emissions technologies. Those links are on the episode page at podcast.smartprosperity.ca. Now it's time for something we do every show. It's called the 60-Second Report. It's where we invite the author of a new and important report to sum it all up in 60 seconds or less. This week, I'm welcoming Dale Marshall, who's summing up a new report written for Environmental Defense by Jim Stanford from the Center for Future Work on the transition for workers in the fossil fuel sector. Dale, over to you.
Economist Jim Stanford looked at the challenge for Canada of phasing out fossil fuels over the next 20 years and transitioning workers and communities towards other economic opportunities. There are three big conclusions from the research. One, time is the best friend of transition. If we give workers and communities the tools and support in advance, we can avoid much of the disruption and pain that will be caused by waiting till this change is forced upon us. Two, the transition is manageable and in fact has started already. Oil and gas companies have shed 50,000 jobs over the last 6 years. Over the next 2 decades, we're looking at 4,000 jobs transitioned every year. The Canadian economy creates that many jobs every 5 days. Larger transitions have been undertaken in Canada and elsewhere. Three, programs can assist workers in making the transition through retirement or training for other good, well-paying jobs, and for communities to diversify the economies over time. For the full report, go to environmentaldefense.ca/steadypath.
Thanks, Dale. And for a link to that new report, you can also visit this episode's webpage at podcast.smartprosperity.ca. Now, the green economy is a busy space, and there's only so much we can cover in depth on this show. For all the rest, I turn to my colleague Mike Moffat. He's the Senior Director of Policy here at Smart Prosperity Institute, and he's going to share 5 other things happening in the green economy this week. Mike, over to you.
Hi, thanks for having me. So here are the 5 other things I'm watching this week. Number 1, Prime Minister Justin Trudeau announced plans for the federal government to spend nearly $15 billion over the next 8 years on public transportation projects. Part of that funding will go towards stable and predictable funding for municipal projects for everything from subway extensions, electrifying transit fleets with zero-emission vehicles, to walkways and cycling pathways. Number 2, Denmark's government has agreed to take a majority stake in a 25 billion British pound artificial energy island, which is to be built 50 miles offshore. The island will initially have an area the size of 18 football fields, and in its first phase will be able to provide 3 million households with green energy. Number 3, pollution from fossil fuels causes 1 in 5 premature deaths globally, suggesting the health effects of burning coal, oil, and natural gas may be far higher than previously thought. Parts of China, India, Europe, and the northeastern United States are among the hardest hit areas, according to a new study published in the journal Environmental Research. Number 4, Tesla billionaire Elon Musk is offering a $100 million carbon capture prize. To win the competition, teams would have to create and demonstrate a solution that can pull carbon dioxide directly from the atmosphere or oceans and lock it away permanently in an environmentally benign way. And number 5, Quebec Premier François Legault has reversed course and reapproved an Indigenous partnered wind farm, noting that wind investments are now more cost-effective than hydro in the province, while at the same time leveraging hydro assets. I'm Mike Moffat, and those are the 5 other things I'm watching this week.
And that's it for today's show. If you just can't wait until the next episode, check out our previous episodes, which cover everything from the changes happening in Canada's car manufacturing sector to the ins and outs of Joe Biden's climate agenda and what Conservatives need to do to reclaim the climate issue, and much, much more. Those shows and others are on our website at podcast.smartprosperity.ca, also on Spotify, Apple Podcasts, YouTube, wherever you stream your podcasts. Thanks again for listening. My name is Eric Campbell. The next episode is out March 3rd. I hope you'll tune in again.